So the next context that we need to understand is when an object is moving under the influence of gravity, there are certain terms associated with it. For general communication, it is important we understand what those terms actually mean. So we are going to see two things. One is, first we'll understand the definitions of those terms. Second is, we will try to derive the mathematical value of those terms. So in this slide, we'll be discussing about the definitions. So what are the definitions? What are the terms for which we are going to see definition? That is maximum height, time of ascent, time of descent, and total time taken. So the first one, the concept of maximum height comes for an object which is projected vertically upward. Generally, when you project an object upward, what happens? It goes to a certain height, stops at a particular point for an instant, and then comes back in the downward direction. It is not possible that the object is not taking a pause at that particular position. It is not possible for the object to come down. What would have happened? It would have continued to move in the upward direction only. Right? So what is the maximum height? It is going to be the distance traveled by the object from the point of projection to a certain value where its velocity becomes zero. Make sense? Right? So the first term that we are going to see is maximum height, and maximum height is represented by the symbol capital H, right? For which the definition is, it is the highest point reached by a particle projected vertically upward. At this point, what happens? The velocity becomes zero. This is a very, very, very important point. Because whenever we see the word maximum height, the first thing that should come to our mind is the velocity at that point is always zero. Clear? The next term is time of ascent. So here, if you see, time of ascent is a term that is derived from ascending. So when the object is traveling upward, the time taken by the object to travel from the point of projection to the maximum height is what is called as time of ascent, right? So the time taken by the particle to reach its maximum height from the point of projection is what is called as time of ascent. So the next concept that we are going to have is obviously the reverse of it. What is the opposite of ascent? It is going to be descent, right? So time of descent is going to be the time taken by the particle to fall back from the maximum height to the point of projection, right? And the last term that we are going to see is called as time of flight. So that is also logically understood term. So what do you mean by time of flight? The total time of flight is nothing but the time of ascent plus the time of the descent, right? So the total time of flight is the total time taken by the particle to go to the maximum height and come back to the point of projection. So time of ascent plus time of descent is the total time of flight. So these are the basic definitions. Okay. First, after understanding the definitions, let's see the derivation, right? Then you can copy it. Okay. First, now we'll see the derivations of maximum height, time of ascent, time of descent, and the total time taken. So for this, what is the important point? What do we need? We need an object that is traveling vertically up, right? So for that, what we will do is we will take this surface as the fixed surface, which is the ground. So from this point, what we are doing is we are going to project a particle vertically in the upward direction. So if I ask you to describe its journey, how is it going to be? First, from, let's say, point A, it is going to go to some point B, where at point B, as per the definition, if I call that point B, if I say the distance between AB as the maximum height, what is that point B supposed to be? What should happen at that point B? The velocity of the object should become zero. So at this point, the velocity is going to be equal to zero. If this happens, then this distance is what is called as h. Clear? So our first job is to find out what is the value of h. So since velocity at that point becomes zero, you can either use the equation v is equal to u plus at or v square minus u square is equal to 2s, because these are the two expressions which have final velocity and initial velocity involved. Right? So, but I will not use v is equal to u plus at because I'm not interested in time at this point in time. I'm interested in maximum height. So first, for maximum height, that is h, what equation are we using? Using v square minus u square is equal to 2as. What is the value of v? 0. V is the final velocity during the journey. It is 0. So 0 square minus, what is the value of u? It is u only. It is u square is equal to 2 into, the important question to be asked is, when the object is traveling upwards, in what direction is the acceleration due to gravity acting? Acceleration due to gravity, irrespective of the direction of motion of the object, will always act only in the vertically downward direction. This is an important point to be kept in mind. Irrespective of whatever is the motion, whether the object is vertically upward, vertically downward, traveling like this in a parabolic path, whichever path it is going to travel, g is always going to be in the, you should not say g is in the downward direction, you should use the word g is in the vertically downward direction, means it is always perpendicular to the surface, the bottom surface. Is the point clear? So g, what is going to happen in this case is, now I'm going to introduce the sign convention. For all the vectors in the upward direction, I'll consider it to be positive, and all the vectors in the downward direction, we are going to consider it to be negative. So 0 square, anyways, no magnitude, minus u square is equal to 2 into, what is the acceleration due to gravity? It is minus g into, what is the displacement? Should I take it as positive or negative? Displacement is taking the upward direction, right? So I need to consider that to be positive as per the sign convention. Having said this, minus u square is equal to minus 2g into h. Minus and minus are gone, which implies u square is equal to 2gh. And what is our interest? To find the value of capital H. So rearranging this equation, you will get h is equal to u square divided by 2g. So the expression for maximum height is u square divided by 2g. This is the first expression, right? So what is our next job? So we need to find the value of time of ascent and time of descent, right? So I'm going to use the same diagram. For the second case, to calculate the time of ascent, which is going to be TA, I will use the equation. I'll use the equation V is equal to U plus AT, because in this expression I have time and relation between velocity and final and initial velocities. Clear with this? So taking this, if I put V is equal to 0, so 0 is equal to U is U only plus acceleration due to gravity is minus G into the time, I'll call it as TA, right? So when I rearrange this equation, what will I get? Minus U is equal to minus G into TA, minus and minus will get cancelled. What is the value of TA? So TA is equal to U divided by G. So the time of ascent is equal to U divided by G, where U is the initial velocity. So this is the second expression to be remembered, right? Now the third expression that we need to derive is time of descent, right? Let's look at that also. So next one is time of descent, which is called as TD. So for that, what we will do is, H is there, right? This point B, V is equal to 0. And this point, it is U like this, and it is lying on a fixed surface. Now the question is, for time of descent, it is obviously important for us to consider the downward journey. So when I take the downward journey, right? So when I take the downward journey, for the downward journey, what is the initial velocity? Let me call it as U1. For the downward journey, let me call initial velocity as U1. So what is the value of U1? It is 0. Reason, the final velocity during the upward journey will act as the initial velocity for the downward journey. What is the reason? Final velocity of upward journey is equal to initial velocity of downward journey. Clear with this? Now, having said this, since u1 is equal to 0, now I need to find the time of descent. So what is the expression which gives me the relation between displacement, initial velocity, time and acceleration? So that is S is equal to ut plus half at square. So I'm going to use S is equal to ut plus half at square. Now, the object is traveling in the downward direction. According to our sign convention which we took, this is positive and this is negative. So since the object is traveling in the downward direction, S should be taken as minus h is equal to, what is the initial velocity during this journey? 0, 0 into time of descent plus half into acceleration due to gravity is minus g, because downward is still negative. So what should I write in the place of t? I'll write td square. So minus, I know the value of h. H is u square divided by 2g. So minus u square divided by 2g is equal to minus g by 2 into td square. Correct? So 2 and 2 are gone, negative and negative get cancelled. This implies td square is equal to u square divided by g square. This implies td is equal to square root of u square by g square, which is nothing but u by g only. Actually, it will be plus or minus, but time generally is not taken to be minus. So it is u divided by g. If you observe, in this case, the time of ascent and the time of descent both have the same value. Right? This is possible only when the air resistance is ignored. Right? We didn't take that into consideration. The only force we consider to be acting on the object is gravitational force. Clear? And obviously, what is going to be the last one? That is the time of flight. What is the time of flight? This is equal to TA plus TD. But I know that TA is u by g. TD is also u by g. This will be equal to 2u divided by g. So T is equal to 2u divided by g. So these are the 4 terms for which we need to remember the expression. So just to quickly summarize, h is equal to u square by 2g. TA is equal to u by g. TD is also u by g, and time of flight is u by g plus u by g, which is 2u by g. So remember these expressions. Okay. Start writing it.